Hey everyone, welcome to CodeTav Management. So we are discussing about the solid principles, right? So we have covered the single responsibility principle and also the open closed principle. So now we will start this L for the Liskov substitution principle. Okay, so let's get started. So here, suppose class A is there and also class B is there. Okay, and class A is the subclass and B is the parent class or the base class, right? So if the class A is the subtype of class B, means the A is the subclass and B is the parent class, then we should be able to replace the objects of the B with objects of A, right? So objects of type A may substitute the objects of type B without changing the behavior, means the correctness or functionality, okay, of our program, right? So the main thing I can write here, like derived types. Derived types means your subclass types, okay? So that must be completely substitutable for the for their base types, right? So this is the main thing, a key part of this Liskov substitution principle. So in layman's terms, you can say, like, if the object of a superclass is there, then it should be replaceable by objects of its subclasses without causing issues in the applications. So we will not change any functionality or we will not correct anything on the program, but it will be replaceable, right? So a child class should never change the characteristics of its parent class, like argument list, return types, okay? So basically, derived classes should never do less than their base classes. So then, Liskov's substitution principle also applies to the inheritance hierarchies. Okay, and also specify that you should design your classes so that client dependencies can be substituted with the subclasses without the client knowing about the change, right? So all the subclasses must therefore operate in the same manner as their base classes. So the specific functionality of the subclass may be different, but must conform to the expected behavior of the base or parent class. Okay. So in general, if a subtype of the supertype does something that the client of the supertype does not expect, then this is in violation of the Liskov substitution principle. So you imagine, like, a derived class throwing an exception that the superclass doesn't throw, or if a derived class has some unexpected side effects, then the definition of it might be a bit complex. Okay, so the only thing is that every subclass or derived class should be substitutable for their base or parent class, right? So now we will discuss about, like, why means why this is required to follow the Liskov substitution principle, means why LSP. Okay, so the first thing you can say, like, this avoids the overuse or misuse of inheritance. Okay, so this is one of the key point, like, through this Liskov substitution principle we get to know, like, we should not write the inheritance principles. We should not extend the parent class unnecessarily. Okay, so it helps us conform to the easier relationship, which is the inheritance. So we can also say that the subclasses must fulfill a contract defined by the base class, right? So I can give you one example. like a square class is there, okay, which derives from the rectangle class. So your rectangle class is your parent class P, okay, and your square class is your child class, okay. So this square class derives from the rectangular class, right? So the square class always assumes that the width is equal with the height, right? If a square object is used in a context where a rectangle is expected, then unexpected behavior may occur because the dimension of the square cannot be modified independently. So I am not explaining this example, as you will find it very easily from so many resources are there for that. So uh, I will show you another example, like suppose a bookstore. Okay, first of all, LSP violations. That example I will show. So suppose one bookstore is there, okay, one bookstore, and that asks us to add a new type of book delivery functionality in the application. So we create a book delivery class, right? So for that, public class uh, book delivery, okay, right? After that, we will take two things. So first one is titles, titles of the books, okay, and also user ID, which will be in the form of integer, uh, user ID, right? And there will be some method like delivery, get delivery locations. So just void get delivery locations, right? So here your logic will be there, right? So here the book delivery service, this is the class that informs the customers about the number of locations where they can collect their order from here. So through this get delivery locations, the customer will get to know, right? So however, the store also sells some fancy poster maps. They only want to deliver to their high street shops. Okay, so we create a new post map delivery subclass. Okay, so for that, mm, public class post map delivery, right? It will be good name. So post map delivery service. Okay, so it will extends the book delivery service, right? Now this will override what the this method. Okay, so later means here the store also sells the fancy poster maps, and it basically overrides the get delivery locations method with its own functionality. Okay, so later the store asks us to create the delivery functionalities for audiobooks. Okay, so now we extend the existing book delivery service class with an audiobook delivery service subclass. Okay, but when we want to override the get delivery locations method, we realize that audiobooks cannot be delivered to physical locations, right? So that's why suppose some public class audio, so audiobook delivery system that's also extends the book delivery service, right? So there also, when you will override this uh, void get delivery, Okay, so here it cannot be implemented since audiobook doesn't have the physical locations, right? So we could change some characteristics of the get delivery locations method. However, that would violate the Liskov substitution principle. Okay. After the modification, we couldn't replace the book delivery superclass with the audiobook delivery subclass without breaking the application, right? So what we can do for that? Just see. So then I can say you the modification. And here I am also writing here for audiobook, no physical location. Okay. So modification required. Okay. Which violates Liskov substitution principle, right? So what modification we can do? So right, first of all, this parent class we need to create, right? And here we will not add this one. We will create another class, right? Like offline delivery. Okay. So public line delivery service extends book delivery service, right? And inside that, I will create the method void get delivery locations. Clear? So then what we can do? We can now this we also do the online delivery system, right? So public, so this one I can copy here. Okay. In this place of I will do the online delivery service, which also extends the book delivery service. And inside that, we will create the method like void get software options. Clear? So through this refactoration of this code, poster map delivery will be the child class of the offline delivery service, right? And it will override the get delivery locations method, okay, with its own functionality. But the audiobook delivery will be the child class of the online delivery service, which is good news. So as now it doesn't have to deal with the get delivery locations method. Instead, it can override the get software options method, okay, of its parent with its own implementation, okay, like by listing and embedding the available audio players, okay. So now what modifications we can do? Just copying these things. Okay. So now it will extends the means poster map delivery will extend the offline delivery service and it will override the get delivery locations. But audiobook delivery service will extend the online delivery service. Okay. And it will override the get software options, right? So after the refactoring, we could use any subclass in place of its superclass without breaking the applications, right? So violations of Liskov substitution principle cause undefined behavior. Undefined behavior means that it works okay during the development, but blows up in production, or that you spend weeks debugging something that only occurs once per day. okay, or that you have to go through the hundreds of megabytes of logs to figure out what went wrong, right? So in this way, you will just substitute one by one and you can easily resolve it, right? So I think you get to know about this Liskov substitution principle, like, right? So here I have discussed about what are the issues were there in this main example. Okay, so these violations actually initially we have created this parent class book delivery service, and then we just created one method get delivery locations, but we get to know like for the audio book delivery service, this get delivery locations is not required as this is the physical locations required for that, right? But for the audio book delivery service is the online service and they are not required the physical locations, right? So for that, we have created the offline delivery service and online delivery service, and this both of offline and online delivery service extends the book delivery service, which is this one. And then for the offline options, we will just extend the offline delivery service parent class, like for the postmap delivery service or anything like for the offline. And for the online, like audiobook delivery service, we will just extend the online delivery service, right? Okay. So now what are the benefits for that? So here, like I also say about the benefits. So here, basic benefits basically we can reuse the code, right? So code reusability is the point. Then easier maintenance. Okay, and also reduced coupling, right? So these are there. So now you can ask me like, what is the main goal of this LSP or Liskov substitution principle? So the main goal of this Liskov substitution principle is to ensure that derived classes or subclasses can be used interchangeably with their base classes. Okay, here this offline delivery service is the subclass and online delivery service also the book delivery services subclass. But here we are not extending the main parent class, right? So this substitute we can use means we can inherit directly, right? So this is the main goal for that. So how does this LSP relate to inheritance in object-oriented programming? So basically, the Liskov substitution principle is nearly related to inheritance as it focuses on the behavior of the derived classes. Okay, so when they inherit from the base class, it ensures that the derived class can extend or specialize the behavior of the base class without breaking any contracts, right? Okay, so next, like how to ensure means the means some questions you can follow, which can be asked. Like first of all, I have discussed about like what is the main goal. Okay, next is like how LSP connected to OP. Okay, means oops. Okay, then common signs for LSP violations. Okay, so for that, what you will answer? So for the common signs of violation include like derived classes overriding methods in ways that are inconsistent with the base class. Like here I have shown you, right? So here this get delivery locations. So here I have uh, also told you, right? This, just a minute. Yeah. So this get delivery system, get delivery location was there, right? For the book delivery service. Okay. But this is not required for the audio book delivery, right? So for that reason, it's not required. So unnecessarily when it overrides the parent classes methods, which is not required for the subclasses, so it will show you the violations for that. Okay, then you will get to know that Liskov substitution principle is violated. Okay. So after that, like, so here, like, how the means the how you can modify, or how you can avoid these violations. So this also example is showing here how modifying, how you can modify your code or refactor your code. That's why LSP will not be violated. Okay, so the modifications. Okay, next is like how LSP is connected with the OCP. OCP means open close principle. Okay, so LSP and OCP are related to the solid principles, and LSP ensures that the derived classes can extend the base classes without altering their behavior, enabling adherence to OCP. So OCP, which states that the software entities should be open for the extension, but closed for modification, right? So suppose one class A is there, right? So open closed principle is saying that it's open for extension, okay, but closed for modifications. Okay, so here also for the Liskov substitution principle, that things I have told, right? Like for this audiobook, no physical location is there, so modification is required. Okay, but when modification required, that violates the LSP. Okay, and also violates the OCP. Means in the OCP, means open close principles, also it's written there. So that means the thumb rule is there, like we cannot modify the code, okay, but we can extend the code, right? So here in the Liskov substitution principle also, it's saying that when something is not required, like this get delivery location is not required here, right? So for that reason, we have just substituted another class from the parent class, like this online delivery system or the offline delivery service from the book delivery service. So we just extending that one, and we are not modifying these things. So we are not, we have just extended by using new method, which is get software options. So in this way, this open close principle and the Liskov substitution principle are connected with each other, right? Okay. So can you the another questions can be shown, like can you provide some example like LSP violation is there? So already I have discussed, right? So main thing is that what is the LSP is, okay, what I have already told you, and what are the violations, means what can be the violations for the LSP, and how you can avoid that violations. So these are the main key concepts. If you will get to know these things, then you can easily answer all the questions from the Liskov substitution principle, right? So okay, again we will meet in the next lecture for the I of the solid principle, right? So if you have any other questions, then you can also comment down below, and yeah, just stay connected and do like, share, and subscribe. Thank you.